Today's topic is about functions. Functions you'll see all through high school. You'll see it in Algebra 1, this class, in Algebra 2, you'll see it in pre-calculus, you'll see it in calculus. So today we're going to just do a little bit of an introduction to them. So first of all, a function is basically a relationship between values. And by a relationship, usually what you're going to see is going to be equations. So, for example, an equation, and it's generally going to be an equation that has two variables, not always, but usually. The ones that you tend to see most are going to be equations that have an x and a y. So the biggest thing about a function that's really, really important is that every x value is going to correspond to exactly one y value. And in this class, the first thing I'm going to ask you is to tell me whether something is a function or not a function. So first of all, let's look at a graph. That's usually the easiest way to tell if something is or is not a function. So remember, the x is the horizontal axis that goes from left to right. The y is the vertical axis. It goes up and down. So something that's going to be a function is going to have an x value. Every x has one y. So, for example, if you have a line, you can also have something like a parabola. You might even have something that's only a half of a line. That's okay. We don't have all of our x's being used, but every x that you have does go with one y value. Sometimes you're even going to have just a random set of points. Believe it or not, this is also a function. So some things that are not functions is going to be anything that you notice that an x value has two y's corresponding to it or more. So for example, if you have something like this, we have a sideways parabola. So you don't automatically look at that and say, oh yeah, some x's have two y's. But if you were to look, for example, right here, you'll notice at this value, you will have a y value up here at that x, and you will have a y value down there. So you'll find that it's anything where if you were to draw a line through it, then you would hit more than one point, a vertical line. That would be what we call a function. Same thing is even if you have a line, but then you have one other point, for that one, if you were to draw a vertical line through there, you would hit 2 points at that one spot. Also, if you have something like this, you have a nice bunch of points, but then suddenly you have another point that's directly below that. That's an example of something that is not a function. Because of these 2 points that are right here and right here, those cause it to not be a function. And you'll also have anything that looks like that. Sometimes you're going to even have more than 2 points that would correspond to one x. So for example, if you right here draw a line through everything, you'll find that you hit 3 different points. So that's definitely not a function. The next part of functions that's important is that they include two things. They include what's called the domain and what's called the range. So the domain is all possible x values. And sometimes you'll see another word for x values, which is also going to be called input values. And then the range, you might be able to guess, is going to include all possible y values. And we call our y values the output values. So make sure that you know those 4 words. You need to know domain, you need to know range, you need to know input values, and you need to know output values. In addition, you also need to know the word function. Those words are going to come up again and again and again. You're going to see it in most of your math classes from now on. So let's go into a few examples. And for all of these examples, I'm going to ask you to do 3 things. The first thing I'm going to ask you to do is tell me, is it a function? And you're just going to put yes or no. Second thing I'm going to ask you is to find, if it's a function, I want you to find the domain and find the range. So for our first few examples, I'm just going to give you some tables. Once I go through the first one, if you want, you can feel free to try the second one on your own and then fast forward through it and make sure that you get the answer right. So the first example, number 1, I'm going to give you a table with a bunch of values. And this is just a fancy way to write an XY table. I just put output and input on there in addition to X and Y. So there's a few ways to figure out, is this a function? That's the first thing we're going to find. We want to know, is it a function? So what I'm going to do in order to find it, I found that by far the easiest way to figure out if something is a function is to graph it. So remember, X is the horizontal, Y is the vertical. So graphing this, I'm going to have the point 0, -1. I have 3, 0, 6, 1, 9, 2, and 12, 3. So we want to know, is this a function, yes or no? So the way that you can know is you need to make sure that every x has only one y that goes with it. So when x is 0, we have y is -1. We're good there, actually. And you'll find that it's the same case when x is 3, y is 0. When x is 6, y is 1. There are no repeated values. We don't have any x's that have more than one y, so we're good. So because of that, we're going to say, yes, this is a function. And now, since we know it's a function, we can also find its domain and range. So domain and range are usually among the hardest thing to find. Luckily for these examples, they're actually not too bad. So my domain is just going to be the x values that I have. It's going to be 0, 3, 6, 9, and 12. The range is going to be all the y values I have. I have -1, 0, 1, 2, and 3. And that's all we're going to do for this one. So go ahead and take a look at number 2. See if you can figure out on your own. Just take a second to look at it. If you want to pause, you can. See if you can figure out, do you think it's a function or not a function? So I'll go ahead and draw it, and then you can check based on that. So I have a point at -2, -3. I have a point at -1, -2. 0, -1. I have a point at 1, 1, and I have a point at 2, 1. So this one is a little bit tricky because you have x equals 1 and x equals 2 both have y equals 1. So if you look back at your definition of this, a function is where every x has only one y to go with it. So when x is 1, right here, x is 1, we have one y, which is y is 1. When x is 2, we also have one y, which is that y is 1. So it looks like it should be no, but actually it's a yes. You are allowed to have a y value that repeats. The only thing is that you can't have an x value that has two y's that go with it. So this one, the y value has two x's, that's fine. So now our domain is going to be the same as in the previous problem. Once again, I would like you to see if you can list the domain and the range. See if you can do it on your own. If you want to pause, that's probably a good idea. So the domain is just going to be -2, -1, 0, 1, and 2. The range is going to be all of our y's. So my first one, I have -3, I have -2, -1, then I have 1. I have another 1, but I'm not going to bother writing 1 twice. I just need to write it once. So for number 3, first thing I'm going to do is I'm going to graph it. I have a point at 0, 1. I have a point at 1, 2. I also have a point at 1, 3. And I have a point at 2, 4. So I want you to look at this and think, what do you think? Is it a function or is it not a function? Yes or no? So I hope that you thought it was no. The reason it's a no is because at x equals 1, you'll find that you have 2 y values. Since there's 2 y values that go with that x, you are going to say that no, it is not a function. If you want, one thing that can help you, I mentioned it before, is that if you were to draw a line through it at that point, a vertical line there, you would find, hey, I had 2 points when I draw that vertical line at x equals 1. So you'll find that the answer to it being a function is definitely a no. So for the remainder of the problems that we're going to do today, I'm going to actually give you a graph first. So for number 4, I have this graph. The first thing I want you to do is decide, see if you can think about it. Do you think that this is a function? Yes or no? If you're stuck, maybe look back at the pictures, the initial examples that we had in the beginning, and you will find that this is a function. So you're going to say yes. The reason is because every x that you have is going to have only one y that goes along with it. There's some x values that actually don't have any value that goes with it. That's fine. You're allowed to have like x equals -1. There is no y. There's also no x on the graph. We're only looking at the part that I put in white, only looking at the graph. So this is a function. The first thing we need to figure out is our domain. And I've noticed that these ones are generally the hardest parts of all of these problems, is finding the domain and the range of the graph. So what you're going to do is you're going to look along the x-axis, which remember is the horizontal axis. You're going to see what x value it starts at and what x value it ends at. So if you notice, it starts right over here at x equals 0. And it actually is going to, it keeps on going. We have an arrow that shows that it will go on forever and ever. So it would end at infinity. So the way that we write our domain is that x can be any value greater than or equal to 0. So you're going to write it as x is greater than or equal to 0. So now, maybe see if you can think the same way. See if you can figure out, what do you think the y, the possible values of y, which is the range, are going to be? So the way that you find the range is kind of doing the same idea. Remember, the y is our vertical axis. It's going up and down. So if you look up and down, the first place that it starts is right about here. It's actually at -1. Once again, even though it looks like it keeps going off to the right, it actually, we're going to assume that it keeps going up. So because of that, we're going to assume that it goes on forever and ever and ever and ever. So we are going to say y is greater than or equal to -1. So now, if you'd like, pause and see if you can do number 5. If you're still not 100% sure, then don't bother pausing. But I would recommend that you maybe try to take a guess, see if you can figure it out. So, first of all, this one is a function. We're going to say yes, because every x value that we see on the graph has only one y value that goes along with it. Our domain, we're going to figure that out by seeing where the x starts and ends. So you'll notice that it starts at -2. It never ends. It goes on forever and ever. It's infinite. So we're going to say for our domain that it's going to be all x values greater than or equal to -2. So now our y, remember, is the up and down, the vertical axis. It's going to start down here at 0. So our range is going to be y is greater than or equal to 0. So for number 6 and 7, I have 2 more graphs. If you'd like, you can try to figure out if they're a function, and if you say yes, then try to figure out what the domain and the range are. So go ahead, if you want to do that, you can pause. So then number 6, you will find that yes, this is a function. The reason is that every x has exactly one y. And you can also, if you want, you can draw a vertical line through every single point that you draw a vertical line. You'll only hit one part of the graph. So then your domain, you might look at this and say, oh, our domain is -3 to 3, which is kind of understandable. Unfortunately, because of the arrows at the end, that means that we can go on forever and ever and ever. We're going to hit every x value eventually, and it'll just keep going. Both to the left and the right, it's going to be infinite. So we say for our domain, since it can be anything, we say all real numbers. So we won't worry about numbers that are not real right now, but for now, all you're going to say is all real numbers. So then the range is going to be our possible y values. Remember, we're looking up and down. So you'll find that your y starts down here at y equals 0. So, and then it goes above it. So we're going to say that it's going to be y is greater than or equal to 0. The last one. This is another one we're going to say, yes, it is a function. And so the domain, you'll notice that we start, for our x values, we start at -3, we end at +3. So the way that we're going to write that, we're going to start at -3, we're going to end at +3. It can be, x can be anything between those two. So we're going to write it like this. We would read that as -3 is less than or equal to x is less than or equal to 3. Or you can also say x is between -3 and 3. So that's the notation that we would use to write that. Now the range, you're going to look at your highest possible y value and your lowest possible y value. So the highest possible y value that you have is going to be at y equals 2. The lowest, it's a little bit harder to tell, but you'll find that it's going to be down here at 0. So your range is going to be everything between 0 and 2. So what we're going to do is we're going to do 0, we're going to do 2, and we're going to do y in between. And we're going to write it in the same format. Make sure on these that you are, first of all, putting the numbers in order. We have 0 is first and 2 is last. So 0 first, 2 last. The second thing I want you to make sure about is that your range is always going to have y in it. Your domain is always going to have x in it.